I want to know what the chances are of this coin landing on heads when I flip it. Well, I won't know the answer unless I do an experiment. I need to flip the coin. How many times should I flip it? Once? It landed on heads. What happens if I stop there? I could write an article and say, based upon my observations, the chances of this coin landing on heads are 100%. I could even put a graph in there to show my flip. The one time I flipped this coin, it landed on heads. But doing this one time doesn't tell me much. Only doing a thing once is not an experiment, it's an anecdote. If you ever hear someone talking about anecdotal evidence, this is what they mean. The sample size of the experiment was really small. In this case, just one. You hear anecdotal evidence all the time. The food at that restaurant was awful. I ate there once and it was terrible. I mixed vodka and Red Bull and nothing bad happened. Don't feed your child banana. I did once when my little was 2 and had to take her to the hospital. These are all anecdotal. They're experiments with a sample size of 1. Would the meal be just as bad if we ate there multiple times? Would mixing vodka and Red Bull be just as safe if we did it every day? Most likely not. So how do we increase the accuracy of our experiment? We need to increase the sample size. Let's flip the coin again. Heads again. We're 2 for 2 on heads. So far, 100% of our coin tosses have been heads. Let's flip again. Tails this time. Now it's come up heads about 67% of the time. The more we flip, the more data points we have. We already know the chances of heads for a coin are about half, and we can see on our graph, the more we flip, the closer our percentage gets. This is the importance of sample size. It's true when you're collecting people's height, test scores, movie reviews, you name it. The larger the sample size, the more accurate your data is. I'm Abby Cook with Lizard Brain Learning.